Hello, this short video here will be an overview of basic measurements, measurement scales. So this is going to be real important as we move forward when we inspect our data, when we collect data. When we set up our data set, we want to be very sure of the type of data that we have collected. So this is a question that you definitely want to talk about and think about when you're creating a survey and where you're creating the actual questions that are going to be used in the survey. So the instrument itself will dictate to a great degree what type of data you have, and this is a very, very important thing to understand. This is definitely a number theory discussion, so we want to make sure that everybody, you're comfortable understanding and being able to identify the data that you have and the properties your data takes on. So some terms then that we'll want to understand and know. One would be properties. So properties are specific features or characteristics then of whatever the object is that you're measuring. So it could be a consumer or a product or a competitor or whatever. Whatever you're measuring has characteristics, and those characteristics or properties distinguish them from each other. So it's something that we use to be able to identify the objects that we're measuring. There are two types of, generally two classes of properties: objective properties and subjective properties. So objective properties are ones that are physically verifiable or easily identifiable types of objects or types of properties. Subjective properties tend to be something that happens inside the object that we can't directly observe. So we sometimes call these things constructs, or these might be latent variables, and we'll talk more about those here in a minute. We have measurement, which is another concept. So the measurement of a property would be the number that we retrieve that indicates the degree to which the property exists. Okay, so how much of the property is being possessed by whatever the object is we're studying. And then another term we'll use a lot is something called a scale. So a scale would be a set or a range of possibilities of which we could measure a property on. And again, we'll talk more about these things here in a little bit. As an illustration, we have this diagram here, this kind of flow of items. We have the object that's being under investigation, which would be our subjects that we're studying. Then we have different properties. In this case, we have the property of age, gender, preferred brand, and then some type of an opinion. And that opinion would be, a subjective property. Age and gender would probably, and preferred brand, or age and gender for sure would be objective. Property, preferred brand, that would probably be something subjective. Although it can be measured in an objective way. So the scale is the next category here. So the scale is the actual way in which we're measuring the different properties, and you can kind of see here the options that are available. So within the scales that have been chosen to measure those properties, and then we have some type of measurement result. So this kind of puts in a picture all of these different concepts that we want to think about and the process in which we want to develop our measures. So moving forward, I mentioned objective properties. Objective properties, again, are ones that are physically verifiable. They tend to be very easy to measure. They usually use a single item on a questionnaire or a single question. So a lot of demographic variables are objective variables. Purchase behavior, sometimes an objective property. And we use objective properties quite a bit. They're easy to measure. Subjective properties are much more difficult to measure. They tend to be something that is unobserved, something that we can't directly see. We sometimes call these concepts constructs or latent variables. They are often, in what we measure, often things that refer to like attitudes or opinions, maybe some intention to behave or something along those lines. They tend not to be physically provable, but through a series of questions, we can usually measure something like this fairly accurately, depending on what the construct is. So for subjective properties, then, we have to translate the mental idea that's going on into some type of measurable, medium, so we can move forward. We typically ask several questions then when we're doing creating some type of a construct. And so to continue then this idea, and maybe another illustration of using a series of questions, which again may be referred to as a scale. A scale may be a series of questions that we use too. Many constructs are used in marketing, as I've mentioned before, like loyalty and satisfaction and innovativeness. These are all things we can't directly see. So here's an example for the construct price expectation. And what we have, and this is a real scale, this is something that we would use in research, like we would put these 3 questions in a survey, and we would ask respondents to give us a range or an answer to these 3 questions, and then we would put them together, and together the 3 questions form the construct price expectation. So my overall experience about prices are, and this would probably be on a scale like from unfavorable to favorable, and maybe it's like a 7-point scale where if somebody did a 1, it would mean unfavorable. If they were on the other end of the scale, a 7, it would mean favorable. So we'd have like a numeric representation on a scale for that question. We'd also do the same for I expect the prices to be, and maybe that would be like, again, we could do unfavorable, favorable for that, or low or high or something like that. Then here's the third question, compared to other stores, the prices are most likely, and again, low or high or unfavorable, favorable, something along those lines. It's good to keep the same scale anchors. You don't necessarily have to, but it is good to do that. It's ideal to do that. But the point here is that these 3 questions would indirectly measure price expectation. And then when we put the 3 together they would form this construct called price expectation. So this whole idea of a subjective property becomes fairly difficult to measure, and so we have to be very careful about how we construct surveys in order to measure things with a lot of validity and reliability, especially when we deal with these types of mental concepts. So moving forward, when we think about different questions, different question types, and the data that we receive, the data has what we call properties, and there are 4 specific properties that data can have. One would be description, and so all data has some type of a label associated with it. That label, whatever that label is, would be its description. So it's the unit in which the property was measured in. Okay, so and we'll have some examples of this as we move forward. Order is another property. So order basically means that whatever the answers are that are provided, they have some like level to them related to each other. So one is better than another. So like if you have a set of playing cards and you have a jack, a queen, and a king, those 3 cards have order. Like one is better than the other is better than the other. If you had a hand and you were playing cards, you'd probably prefer to have a king over a queen over a jack. So in that sense, you have order. The third property would be distance. And so when two objects have the same distance between them, they're distant. They also have order, they also have description, by the way, as well. They also have the other properties too. So distance means that there's some equal distance or set different distance between between what could be provided in terms of an answer. Origin is the final level. Origin means that there is what we call a true zero or a natural 0 point, where 0 has some significant meaning within the scale itself. Okay, so, and again, we'll have maybe some examples here. Age, for instance, is a good example. Like age 0 has significance and it means something, and that's where the scale begins. So, so don't forget, so properties, the four different properties that we have here, they exist with all the measures. So like whatever measure we have, it'll have at least one of these, and it may have all four of these or something in between. Okay, moving forward then, we have different types of scales or different types of measures as they relate specifically to the properties we just talked about. Okay, so nominal scales are scales that have description, but they don't have any of the other properties. So, for instance, gender. Gender would be a good example of a nominal scale. So we have male, we have female, and, you know, like we're not saying that male or female has order. There's not one that's better than the other. There's not a one comes before the other or after the other. There's also no distance, and then of course there's no 0 point because it's not numeric even. It just has a label. That's all it has. All that variable has is a label or a description. So it is a nominal variable. Ordinal scales are ones that have order as described before, and they also have a label, okay, so or a description. So anything that can be placed in an order, it makes, you know, so if I said, what's your educational attainment level, and I list high school, graduate, some college, college graduate, and then postgraduate degree. So there's like 4 different levels and they all go in order, but they're not necessarily equally distant. They all have a label, but they all go in order. We had high school, college, some college, we had college degree, and then we had post-college degree. So there's an order implied there and they're labeled. So those are, and we refer to those as categorical data. So this would be non-metric categorical, you know, types of data. The other 2 types of data that we have often go together. They're often used together and maybe even interchanged for each other sometimes. But we have interval scales and then we have ratio scales. So interval scales mean that the data is labeled, that there's an order, so the lower is lower, the higher is higher, and that makes sense. But it also, in interval scales, you also have equal distance between the options. So a typical scale that we'd have, like a Likert-like scale, which ranges between agree and disagree, like on a 10-point scale, the difference between 2 and 3 is like the same as the distance between 7 and 8. The distance is the same, so it's a distance type of a thing that matters, okay, in an interval scale. So we have distance, we have order, and we have description with interval scales. And again, those are metric. Sometimes we might also call those continuous variables too. Ratio scales, well, no, the interval scales probably wouldn't be ratio, but ratio scales would be. So ratio scales, as I mentioned before, like age would be something that would have a true 0. Income level might have a true 0. And so basically what's happening is the 0 as a placeholder has meaning in the numeric scale that you're using. So ratio, interval, Those are metric continuous variables. We have other variable types. Dummy variables is something we'll talk about later in other videos or other recordings. So dummy variables are nominal, and they are only indicate the presence of something or the absence of something. So they are typically referred to as a 1 or a 0. Sometimes we think of these as binary, but they could be more. It could have more than just a 1 or a 0. You could have so you could take gender and make it a dummy variable, and you could have one column that's for male, and everybody who's a male gets a 1, and everybody who's not a male gets a 0. You could get another column that says female and do the same for that. You could actually have a third column that says other or prefers not to answer. And then for those who preferred not to answer, they would get a 1 and everybody else would be a 0. So dummy variables are actually things that we use a lot to reclassify our data and organize our data into groups. And again, we'll have other. As a visual description of these 4 different data types, again, we have non-metric, sometimes refer to these as qualitative, but they're non-metric data, would be nominal scales, ordinal scales, right? And then we have our metric data, which would refer to interval scales and then ratio scales, just as a kind of a summation of these different scale types. And again, make sure that you remember the properties that are associated with each of these. Okay, so for nominal scales, we have description. For ordinal scales, we have order and description. For interval scales, we have distance, order, and description. And then for ratio scales, we have all 4. We have the origin idea, we have distance, we have order, and then we also have description as well. Okay, so just don't forget that their properties are associated and they really define what these are and how they go together. All right, so where this matters for us is that for nominal data and for each of these data types, you can only do certain types of statistical analysis. So for nominal data, we look at, like if we're going to describe nominal data, what we would do is count how many times one of the options was chosen. So when we talk about like what is the central tendency of a variable, if it's nominal, then we think about mode, we think about frequency, we think about like the percentage of the like what percentage of the respondents chose male, what percentage chose female, how many chose male, how many chose female. Those are counts, those are frequencies. We could do which were more, male or female, that would be the mode. Okay, so that's the type of like way we use this data if we're going to describe it. Again, what we'll typically do is use this type of variable to split up our groups, split our data into groups, and maybe do between group analyses. That's kind of how we would use that variable itself. Ordinal data is similar to nominal data, except that what we can do is we can combine groups together. So like for instance, in the example before, if I had high school, like people who had a high school degree, and then they had people who had some college, and we had people who had a college degree and then a postgraduate degree, what I might do is just group together those that have a college degree and a post-college degree, and then I'd have maybe my other group be people who had a high school degree and some college, and then I could group those two together and maybe do a between group analyses where so you can combine groups sometimes if you want with ordinal data. But again, you're talking about modes, frequencies, percent distributions. You can do cumulative distributions or percent distributions, cumulative frequencies, in other words, there as well. With nominal with nominal and ordinal data, then we're think of them as our factors as opposed to maybe our variates or variables. They are non-continuous variables, so we just have to treat them a certain way. You can never take a numeric mean of nominal or ordinal data. You can't do a standard deviation, you can't do a variance. It doesn't work. It doesn't make sense for you to do that. So just be aware of that. And also in SPSS, you have to specify your data type. So you need to know this anyways if you're going to set up your data set correctly in SPSS. When we move over to interval and ratio data, we can do a lot more. That's fun and interesting. So with this type of data, we can take arithmetic means, we can do ranges, we can do variance, we can do standard deviations, we can do practically everything that we want to do statistically to our data when we have interval and ratio data. So again, we can do averages, and we can do regression, and we can do all of that type of stuff. So that's important just to remember and recognize in and of itself. Another term that we want to work on here and make sure we're familiar with is the variate. And again, the variate then would be the series of variables that go together into an equation. So the variate is a linear combination of variables that's empirically determined by some type of a weight or a coefficient. So again, if you look here, this formula looks a lot like a regression type of a thing where we have these individual variables, x2, x1, all the way to xn, and then we have some type of a weight that is associated with it. So that series of independent variables then create the variate that would go together into an equation. And so this is then the variate that we refer to. Okay, so again, it's a term that you should be aware of. When I talk about the variate, I'm talking about the system of variables, or a formula, or a model that represents something of interest. Okay, other types of variables that we're going to talk about later in other lectures, but ones that you should be familiar with at least on the outgoing here. Other ways we can describe variables, maybe in a system. So you're probably familiar with an independent variable, and you're probably familiar with a dependent variable. One leads or causes the other. Okay, remember, dependent variables depend on something. They depend on independent variables. Independent variables happen on their own, but dependent variables need to be acted upon, or something has to happen for them to take place, is the way we theoretically model this type of stuff. If we have an intervening variable, we call that a mediator. And so this mediates, it interacts with the relationship between the independent variable and the dependent variable. So a mediator is something that we want to be aware of. And when we introduce mediators, we have second order effects. So we have an independent variable, which is then contributes to a mediator, which is then contributing to the dependent variable. And it could be that there's a mediator. It could be that the independent variable also directly affects the dependent variable too, just depending on how the model goes. If that were the case, we'd call that a partially mediated model, where we have this effect here with the mediator, and then we also have this direct effect going on too. So that could be something that we construct. A moderator is an interaction effect with some other variable. So, like for instance, we might say that this might be some type of income, which leads to some type of purchase behavior, and then the moderator here, maybe that's the weather. like the weather outside. The weather outside's nice, then this is going to be a much stronger relationship maybe because people want to go out and buy. If it's weaker, if it's bad weather, maybe they don't want to go out and buy, and so maybe this relationship is weakened because people are in less of a good mood. I don't know if that's a good example, but basically what we're talking about is a variable that impacts this relationship going across here. The last set, and we actually will have a whole series of talks about mediators and moderators in regression. So it's something that's common that we'll measure quite a bit. The last item on there is an extraneous variable. Extraneous variables are variables that explain some variance in the dependent variable, but we don't necessarily either have data for, we can't control for it maybe. Maybe it's something that we didn't think about when we built our model and we went to try to create a model here. And you want to be aware of extraneous variables if you can. If you have knowledge of the extraneous variables and you can't measure it, then you should at least be aware that they exist. However, sometimes we don't even know they exist. We know there's something impacting the dependent variable that's outside of our model, but we don't know what it is, and therefore we can't capture it. If you know of a variable that is outside and you can measure it, then it might be worth putting into your model and looking at its overall effect. That might be something that you want to do. So extraneous variables then are ones we may or may not be able to capture. All right, two other concepts that I want to briefly touch on would be validity and then reliability. So validity is a theoretical concept that deals with this idea that what we're measuring is reality. It's like what we intend to measure. So we're measuring something and we want to make sure that what we're measuring actually reflects reality the way we think reality works. Okay, so while we can this reality, this whole validity thing, it's not like we can have a test for it. We don't have a statistical test for validity. It's not something that we can numerically quantify, if you will. But we want to make sure that the results that we get make sense to the theory that we've put forward in order to show a relationship that it should happen, it should be there. And there's any number of different types of validity. And so we want to make sure that to the extent that we can, the structure of our data, the way we measure our data, the way we theorize that the variables should go together, we want to the best of our ability, make sure that they are that they make sense, like from a validity perspective, that it's a valid notion that we're trying to put forward. Okay, so the other concept then is reliability. And reliability will deal with how consistent the data is in portraying the truth, portraying what is really happening in our data, in reality, in our sample, in whatever the context is that we're collecting data for. So here's an example that shows the interplay between reliability and validity. Imagine you have a bathroom scale that consistently measures a weight. So it consistently measures like how heavy a person is. However, imagine that the scale was exactly 5 pounds off. So what's happening here is the scale that's being stood upon is reliable. It consistently reports a weight. However, that weight does not match reality. It's not valid in that sense because it's consistently off. But that consistency in and of itself shows that the scale is reliable. It's just not valid. So reliability then deals with this ability to capture the score from time over time, or consistently, like every time I use the scale or use the survey, it consistently reports and measures the same thing. If I use a survey, for instance, today, and then I use the same survey 5 years from now, the question is, like, am I collecting the same data, and am I getting the same type of results? That's reliability. If I use a survey today here in the United States, and then I use the same survey, say, in China, will the survey work the same way and measure the same things between the two cultures? Okay, if it does, then it's reliable. Then that shows reliability. So that's the thing that we want to think about. So while reliable measures may be consistent, consistency can actually be seen as a byproduct of reliability. We typically do not have perfect consistency or perfect reliability, but we want to measure. This is something that we measure. We absolutely measure. We have lots of measures, in fact, for reliability. And we want to make sure that, to the best of our ability, that the data, the instrument that we're using is resulting in data that we can consistently use for the same measures over and over and over again. Okay, so this talk then, this lecture covered a lot of material. We talked about different objectives, different properties of objective and subjective variables. We talked about different variable types like nominal and ordinal and interval and ratio data. We defined a variate, we defined other different types of variables, and we touched on validity and reliability.